Hey everyone, I've got an answer key here for the practice test on rational functions. There's a lot going on. It's a pretty challenging unit. You have to read the directions very, very carefully. As you kind of scan the page here, you'll see that we've got some potential rational functions, some polynomials, and some that are neither. So it says classify each, whether it's a polynomial with a P, rational with an R, or a neither. For any polynomial, rewrite it if you can in standard form. Give its degree and lead coefficient. These are really important things. For any rational function, rewrite it if necessary in factored form and give any asymptotes. That is also very important. Don't forget, vertical and horizontal. For all others, sort of say the part that disqualifies it. So as you look at this is a rational function. It's got irreducible x's on top and bottom. When we factor it, and consider the degree of this rational function. It's degree 2, so the two factors give us 2 vertical asymptotes. When is this going to be 0? At positive 1. When is this going to be 0? At negative 6. Once you've got the vertical asymptotes, consider bottom for the horizontal. Bigger degree on the bottom, so the horizontal asymptote is at 0. Okay? Thank you, Mr. Williams, for writing up this answer key. We're collaborating on this practice test a little bit. Hopefully this is going to make some sense, help you out to get ready for it. Here, this is the disqualifier. The bottom is a polynomial, but this is not a polynomial. Okay, so it's neither. And that thing is what disqualifies it. The degree is to 1/2. It's not a positive integer degree. Here, this is a polynomial. You can see the degree is 4. The lead coefficient's a little invisible 1. And it's already in standard form, going 4, 3, missing the x squared term, and then 1, and then number. On this one now, looking very carefully, we have a polynomial in the top. We have a polynomial in the bottom. It doesn't cancel magically and go away. So we factor. Here we've got x plus 3, and then x minus 2. And in the bottom we have x and x. Again, nothing cancels. The vertical asymptote is at x equals 0. The horizontal asymptote, now Bobo is telling us that it's eats dc. The exponents are the same, so we divide lead coefficients, and 1/1 gives us a horizontal asymptote of 1. Looking at this top one is a polynomial. The bottom one, that's a polynomial. However, this 3 goes in evenly to each of those. It's kind of a dead giveaway. They're all divisible by 6, but even if that's like a 7, you can make that 7/3. When you divide everything in, it's a polynomial. It's now written in standard form, and it is a degree 2, again with the lead coefficient of 1. All right, for now this is one where even though you're allowed to use your calculator on a lot of this has only got letters, so you have to do some thinking about really what's going on mathematically. As you look at this in factored form, we can definitely get the vertical asymptotes at negative a. You're going to get 0 at negative a, so there's a vertical asymptote. You're going to get one at positive b, because that gives you 0. There's a vertical asymptote. And then you're going to get the degrees for the horizontal asymptote. You've got 2 x's down there, would multiply to make x squared, 1 x up above. Bobo tells you it's bigger on the bottom, and then the horizontal asymptote is 0. Now to sketch the graph, think as you come in, you know a vertical asymptote is this like boundary that as it gets closer and closer is going to almost deflect the function up or down. So we really only need to pay attention to the sign, and you put in a value that's a little bit more positive, a little bit bigger than b, a little bit larger, think of b, and a little smidge bigger. And when I take away b from that number that's bigger than b, this is positive. A is big and positive, that stays positive. It's positive up there, so 3 positive signs can only be positive, so it must zoom to positive infinity. We know it's either going to positive or negative infinity. It's positive, so it goes to positive infinity. You think the same way, but now when we cross that important mathematical boundary, we're on the left-hand side. That's the below side. Slightly below b, when I take away a number that's smaller than b, when I take b away from it, I get a negative sign, so it blips over to negative. These two both stay positive. 2 positives and a negative sign will make negative. So we know it zooms as it comes closer and closer to our asymptote. We know it zooms to infinity, and it goes to negative infinity. Carefully worked out here. and you can see it. We'll scan the key. Same thing works this way. We know it's going towards infinity. Why does it go to positive infinity? Because when it's slightly more negative than A, the top now is negative, the bottom there is negative, but this A is big enough that when I add positive A to a number that's not quite as big as A, this stays positive. Think back to some of our numerical examples if that's not clear. So negative over negative goes positive, and a positive, this zooms to positive infinity. Our last case is a number that's more negative than A. So when I add positive A to a number that's bigger than A and is negative, this is negative, and the whole thing blips over again. Okay? So that one we know is zooming towards negative infinity. How do we know that these go to 0? We talked about that. It's the Bobo routine. So we go towards 0. That's all you need to sketch in. All right? Number 3. Here's an actual example with numbers. We can use our calculator. We do the same type of reasoning. I'll go over this fairly quickly because it's very, very similar to the last one. You look for the zeros. We factor this to be plus and minus 4. This one produces the plus 4, 0. This one produces the minus 4, 0. It's an Eats DC with the lead coefficients of 1, so it approaches 1 in the middle. For the horizontal asymptote. I can consult my calculator. I can think about the little smidge thing, and I'll know that it goes positive. When it flips over 4, this one will go negative. When it gets to this negative 4, the negative x remains positive because you square it. This stays negative, and that's the only positive. So 1 negative makes it negative. Then when I get below negative 4, both of these are negative. That's always going to be positive because we're squaring it, and it goes up to positive. So you get that template with the horizontal and vertical asymptotes, and then your calculator will help confirm it. We do want to get a few more points. Always good to consider what happens when x is 0. When x is 0, you have 0 in the numerator, and 16 will not go away. 0 over any number is 0. You could plot a few more points if you want to, but you don't need to. When you consider the domain and range, the domain is the numbers that you are allowed to plug in. I can plug in any x value and it'll work with the exception of our asymptotes. So my domain is all real numbers, but x cannot be negative or positive 4. What y values do I get coming out? Think of a horizontal line. I'm going to get a y value hitting my pen in every spot except this little tiny gap in here. And so I know that I can be at 0. Because I can plug in 0 and get 0 over 16, but it cannot be quite equal to 1 in this case. You have to look carefully because sometimes they do go below and then scoot back up, but not in this case if you look on your calculator. So our range is that y is greater than 1 or y can be less than or equal to 0. And that is all the bells and whistles. Number 4, similar but different. Notice the degree is larger on the top than it is on the bottom. We cannot factor this because there's no way that you can take that plus 16 and get the middle parts to cancel. If you graph only the bottom, you'll see it's a parabola that goes way above the horizontal line. So there's no zeros. But the x to the third up above means that it does not have any horizontal asymptote. When you graph it, you'll see that this fits that bill. No vertical asymptotes, no horizontal asymptotes. It does this strange kind of a thing like this, okay? The domain is all real numbers, and the range is all real numbers. Don't be too concerned that it always has to look like some of the other ones. Trust your mathematical instincts and your ability to think through what it means to have horizontal and vertical asymptotes, all right? Sorry if that was off camera. All right, last one on this page, number 5. Again, can you factor the denominator? Yes, you can. Can you factor the numerator? Yes, we can actually take out an x squared. When you break it down, you can cancel these two. So really, it's like graphing x squared over x plus 3. This is a button, bigger on the top, so it has no horizontal asymptotes. It has only the one vertical asymptote at minus 3. If you look in your calculator, you'll see it's going to zoom up like this, or if you consider that smidge approach when it's a little bit bigger, you'll get it zooming up. On the bottom, it zooms down. it's going to look like this. That's all you need to do is give it some basics. When I plug in 0, I'm 0 over 3, so it goes to the origin. Consider then the domain is all real numbers except for -3. The range then is what numbers come out. Well, there's this gap here. You can see that it's at 0, 0. You can use your calculator to find the maximum value where you pinch off, and you pinch off like this, and you find the max, and it'll tell you what that value is. You'll see that it's -12 is the highest value you can have. So there's this gap in here where it's never going to be between -12 and 0. So therefore y is greater than or equal to 0. It's less than or equal to -12. Okay. On to the last page here. This is sort of a new way of looking at these problems. Can you invent a function that has the following characteristics and then try to sketch it? So this is reverse engineering here. Start with vertical asymptotes at 1 and 2. So you can start with those factors, x minus 1 and x minus 2. The horizontal asymptote has to be at y. So if we've got a degree of 2 down here, we've got to have an x squared up there with a 5 in front. Then that gives us the ratio when Bobo eats DC. We have the ratio of the lead coefficients, so that's good. And then we need a whole at -3, so we just put in an x plus 3 over x plus 3, and when they cancel, they'll give us a whole. Then you can just type it into your calculator exactly like that, in factored form. You do not need to expand it, and your calculator will show you a graph like this. You can find this quite easily by just plugging -3 in for x and just working it all out. You plug in -3 once you've canceled it, so -3 squared is 9 times 5 is 45. -3 right here minus 2 more is -5. -3 there is then -4. -5 times -4 is, oops, did I do that right? -5 and -4, because that's a -3. Oh, that's 20. That's my mistake. That I think is, what did I say? -5 and -4. Yeah, 20, 20, I think. Anyway, so you can cancel a 5, and you'll get 9/4. 9/4, or 1 3/4. Don't be super concerned about there's no domain and range on this, and you just know that this is going to be somewhere. It may not appear when your screen is only like this big, but if you zoom out, you'll see this little bit down there, and you can zoom in that spot. The most important thing is thinking through writing the equation here. This one I think is maybe a little bit easier for our last problem. No vertical asymptotes means it's going to be like one on the other page, where you can start with like x squared plus 1 or x squared plus 2. X squared plus 1 is great. There's no way you're going to ever get a vertical asymptote there. There's no way that can be equal to 0. You can't square a negative number or any number and get it to be -1 to make a 0. Then a horizontal asymptote at 0, Bobo means it's going to be bigger on the bottom, so I can just have like an invisible 1 up in the top. And then I need to put in holes at -1, so I get x plus 1 and x plus 1, and at 6, I have x minus 6 and x minus 6, and that's my function. I can type it in. I'll see this curve. It kind of looks like our bell curve from stats unit, and then I go to -1, and I put a hole in, and I can go way out here to +6 and sketch in a hole. And if you wanted to give the coordinates at 6 comma something, I guess you could. It would be 36 plus 1, so it would be 1 over 37. And here, if you wanted to give the coordinates, you could do -1 and then plug in 1. And -1 squared is 1, so that would be 1/2. Depending on if the instructions do not say that, but that's a little extra. Okay, good luck.